We're asked to find the two smallest positive angles that satisfy the following condition. Secant A is less than 0, and the reference angle for angle A is equal to 1.0687 radians. Remember, secant theta is equal to the reciprocal of cosine theta, and since cosine theta is equal to x divided by r, secant theta is equal to r divided by x, where r is always positive, and therefore the sign of x indicates the sign of the secant function. And since we know secant A is less than 0, we know the terminal side of angle A must be in quadrant 2, where x is negative and y is positive, or in quadrant 3, where x is negative and y is also negative. Again, if x is negative, the secant function value will also be negative. And because we're looking for the two smallest positive angles that satisfy the given condition, the smallest possible positive angle would have the initial side along the positive x-axis and the terminal side in the second quadrant, and therefore this should be the smallest possible positive angle, where the reference angle is 1.0687 radians, which is the angle between the terminal side of the angle and the negative x-axis, this angle here, 1.0687 radians. Notice how to find this angle. We would take pi radians and subtract the reference angle of 1.0687 radians. Before we find this difference, let's determine the second smallest positive angle that satisfies the given condition. The initial side would be along the positive x-axis, and the terminal side would be in the third quadrant. So the second smallest positive angle would be this angle here. But again, the reference angle is still 1.0687 radians, which is the angle between the terminal side and the negative x-axis, this angle here. Notice to find the smallest positive angle in the third quadrant, we would have to take pi radians and then add the reference angle of 1.0687 radians. This is the second smallest positive angle that satisfies the given condition. If we look at our notes below for a moment, if angle A is between 0 and 2 pi radians, and angle A terminates in the second quadrant, angle A is equal to pi minus the reference angle, which we found as the smallest positive angle. And then if angle A terminates in the third quadrant, angle A is equal to pi plus a reference angle, which we found as the second smallest positive angle. And now let's go to the calculator and get decimal approximations for these two angles, accurate to 4 decimal places. We have 2.0729 radians and 4.2103 radians. I hope you found this helpful.